Hello, everyone. Finally, we have a Unit 2. Unit 2, we have Chapter 5, Chapter 6, Chapter 7. It's about the probability. Okay, let's talk about the Chapter 5. We have 4 sections here. So 5.1, basic probability. So Chapter 5, it's about the probability. Chapter 6, 7, it's about the probability distribution. All right? Okay, so we often hear that and we often use probability in real life, right? Yeah, so we have learning objective here. And we have probability forms. It's a basis of inferential statistic. Let me highlight. Yeah, then we know that, right? Flip the coin and then roll a dice, right? And then sometimes weather reports chance of rain. So how much chance of raining today or tomorrow, right? Yeah. So we have a definition, probability. So what is the probability? Probability is numerical measurement for likelihood of occurrence or outcome. We call the event. So probability is number about the event. All right? Okay. So we are using the first letter from the probability P. And then we have event. It depends on event. What kind of event? We are using probability of event E. All right? So read probability of event E. Okay? All right. Then in the probability, we have 3 types. One is a theoretical, or we say the classical probability. So this one is common what we have in real life, right? So flip the coin, roll a dice, what I just talked, right? Oh, I'm checking recording. I'm scared, not recording. Right, that is a theoretical or classical probability. Okay, then we have empirical or experimental probability. That is a relative frequency. We can think about that. Then we have a subjective probability. So I talked earlier, the chance of rain. Yeah. So there will be subjective probability. All right. So let's learn each probability in this section. Okay, so let us do theoretical probability first. So theoretical, also we can say the classical, right? So classical probability, right? So probability experiment is any activity where outcome is uncertain. We have a sample space. I'm just reading here. And some sample space is a list of all possible equally likely outcomes of a probability experiment. Yeah. So it's like a flip the coin. So every side must be equally likely outcome. So means that out on tape, one side, make that side is flip that more often. Make sense? Yeah. So equally likely chance. Each side have same chance, basically, right? Okay. We have an event. So one possible outcome or several outcomes. So we are using uppercase of event E. So first letter event. just using E, right? Yeah. Okay, then what is the formula? So probability of event E equal to number of occurs event E in the sample space divided by total number outcome, right? So basically probability of event E, so number of sample size, sample space, and then number of event E. Yeah, how about that? Just even. Okay, event. Number of event. Yeah. All right. So we have find probability of rolling a six-sided die and getting a 2. So we have a six-sided, right? On dice. Every side has equally likely having chance, right? To be outcome. Yeah, that is equally likely outcome. All right, then getting a 2, that means we have a sample space. That is 1, 2, 3, 4, 5, 6, because it's six-sided, right? Okay, now we want to know about the getting a 2, so probability of getting 2. Yeah, I want to make 2 here. Yeah, number 2, right? Okay, that is number of getting 2 divided by number of sample space, right? Okay, how many number of sample space? 1 through 6 is a 6, right? How many number of getting a 2? Only 1, 2, right? So it's 1. All right, would you like calculate? Yeah, this is 1/6, which is 0.1667. Okay. All right, let's do second one. Okay, so let us do this example, rolling 2 dice. Find the probability of rolling 2 six-sided dice and getting the first one double sixes, and B and C and D, right? Okay, let us do the sample space first. So if we have one die, right? So we get side 1, side 2, side 3, side 4, 5, 6. Yeah. Okay. So second die, we rolling, right? Then we can have from here, how do I like that? Oh, we can make, yeah, quicker. So we have 1, 2, 3, 4, 5, 6, right? The second dice, there's a possible outcome, right? So we can have that 1, 1, 1, 2, until 1, 6. Yeah. Second one. So first die has 2 side, number 2 side, and then we have 1, 2, 6 again, right? So there will be 2, 1, until 2, 6, and same process, right? So 1 through 6. So we have 3, 1 to the 3, 6. Okay, until 6, 6. Yeah, make sense? Okay, Then the number one, the first one said that double six, there's only one double six, right? There's nothing. Yeah, only one. Okay, then let's talk about that. A double sixes. Okay, so then probability of double six. Yeah, there will be number of sample spaces and number of double space. I mean, sorry, double six. Sixes, yeah? Okay, how many sample spaces there? We count 1, 2, 3, 4, 5, 6. Yeah, if we count that is a 36. Or we can calculate it this way. 6 times 6, we get 36. Yeah, so we can do that too. 36. And how many double? Only one double. So that's number one in the case. Yeah. All right. Can you calculate 1 over 36.0278? Okay, thank you. Good job. All right, so let's do second part. The sum of the two faces is equal to 8. Okay, let me bring nice picture of dice from the textbook. Okay, so second part, the sum of two faces is equal to 8. Okay, so here's nice picture of a dice. Sum is 8. Okay, let's take a look. There is no 8, right? There is no 8. Okay, so 7. This is 8, right? This is 8. 6 plus 2, 8. 5 plus, okay, let me highlight. 6 plus 2. And then 5 plus 3 is 8. 4 plus 4 is 8. 3 plus 5 is 8. And 2 plus 6 is 8, right? Okay, so that is 8. Sum is 8, right? So second part, probability of sum is 8. There's a number of sum is 8 divided by number of sample space. Let me denote this way, right? SS, sample space. We just know sample space will be 1 over 36. I'm sorry, 1 over 30. It's a 36. And then sum is how many? 1, 2, 3, 4, 5. 5. Yeah. Now, can you please calculate 5 over 36? It's a 0.1389. Very good. Okay. All right. Let me bring picture here again for C. Okay, here's nice picture again. Let's just see. What's the probability of sum is 1, right? There's a number of sum is 1 over number of sample space. So sample space number of number of sample space is 36. And then let's find out sum is 1, right? Okay, so there is a 2, not 1. There is a 3, not 1. Everything is getting more bigger, not less than 2, right? So we cannot find any sum. Their sum is equal to 1. So it's 0, right? So it's we call it impossible. never happen, impossible, which is 0, yeah? Never happen, impossible. Then the probability of the event equal to 0, yeah? Okay. At least 2, huh? So let us do the last one, the sum of the two faces at least 2. So at least 2 means 2 or more. Yeah, at least means, so we are going to use a lot, at least, in this course, at least. So at least 2 means 2 or more. Means 2 or more, right? Okay. So how much more in that case? Until 36 in that case, right? Because 36 is the maximum, right? No way, it's the sum. Sum is 12. Sorry about that, right? 2 or more. Yeah. Okay, let's count. 2, at least 2, 2 or more. 3, 4, until 7 here, right? How about 3 or more, right? How about 4 or more, 5 or more? Yeah, everything, right? So, yeah, so the maximum is 12. Yeah, because the sum of 2 dice. Okay, so we have, see, different color. Let me see. I am recording, right? See. So probability of sum is at least 2. So that will be number of L sum. We have to make a sum, right? Number of sum is at least 2 over number of sample space. Okay, sample space equal to 36, and we counted sum is at least 2, also 36, which is 1. So 1. So we call this as a certainty. It's 1 means 100%, right? It's 100%. Okay, so here is a summary what we just did. So we have probability is always between 0 and 1, include 0 and 1. And if probability is equal to 0, that means impossible. So we had earlier impossible, right? Never happened. And probability equal to 1, that's certainty. And there will be 1 equal to 100%, right? So we had 100%. Always happen. It's happen. It's happen. Yeah. Okay. Now, we have probability. Another example. Let's do it. We flip the coin 3 times. So head or tail, and then they are equally likely, yeah? So one side is not heavier so that the side come up all the time, right? So not like that. So equally likely chance for the outcome, right? Okay, describe the sample space. All right, let's do it. So 3 times, right? So we have head, tail for the first one. Then second one, also outcome will be head, tail, head, tail. And then third one, outcome will be head, tail, and head, tail. And then head, tail, and then head, tail, right? Okay, then sample space will be the first one head, second one head, third one head, right? First one head, second one head, and the third one tail. Yeah. Okay, let me write down everything. Head, tail, head, head, tail, 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 head, head. I'm doing this one. And yeah, slow, huh? I am doing this one. And head, I'm sorry, tail, head, tail, and then tail, tail. Okay. Head, right? And then last one, tail, right? Okay. Am I right? Okay. Okay. Let me see how many. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 7. I'm sorry, 8. Yeah. 8 outcomes for a sample space. Yeah. Okay. We call this is a tree diagram. Because it looks like a tree in the case, right? Like a branch. Yeah. All right. So what is second part? What is the probability of getting tails? Exactly twice. Exactly twice. All right. So second part, probability of getting tails exactly twice. Okay. So there's number of tails exactly twice. Yeah. Over number of sample space. Yeah. Okay. Sample space is 8 outcomes. So there will be 8. Let's count tails and exactly twice. Yeah. So tail. This is exactly twice. Yeah. So let me write down here for you. Okay, so we have a head, tail, tail, and then this tail, tail, H, yeah? Okay, that's it? Oh, forgot this one. Tail, tail, head, tail, right? Okay, 3? Okay, so 3. Can you please calculate? 0.375. Okay. Oh, you cannot see. I'm so sorry. Yeah, you cannot see. Yeah. All right. Let me see. The last one, right? So what is the probability of getting tails at least once? Okay, tails at least once means we had experience earlier, right? At least once means one or more. So how many more in that case? The maximum is 3, right? Here 3. Yeah. Okay. So let's count and then we can just answer in the bottom. Yeah, because there is no space. At least one or more, 3. Yeah. Tail. Oh, not tail. Tail, 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 right? At most 3 times. So except to head, 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 we get every outcome has tail, right? So 7 out of 8. Okay. So no space. Let me make a little bit shrink this one. Oh. Okay, let me arrange. Yeah, let me just write down here. So C part, probability of at least one tail. So that will be number of at least one tail over number of sample space. So that will be 30, not 36. We had 8 earlier, right? So sorry about that. 8 and at least one. So we had a 7, right? Okay. So what did you have? 0.875. Okay, very good. Thank you. Okay, so let's do empirical probability. So I said earlier, empirical probability, we can think about relative frequency, right? How do you find the relative frequency? So it's a frequency divided by total number of frequencies, right? Okay, so empirical probability. So we have a number of times event occur in the data divided by total number of observation, right? Okay, so look, we have a frequency here, right? So that's why think about the relative frequency. All right, so let's do this example. Survey regarding tattoos. Estimate probability that randomly selected student has no tattoo. Okay, so can you please calculate what's the sum? We learned that, right? So what's the sum means, right? So sum, yeah, summation of, let me just using frequency like F. Yeah, how about that? One 12. Okay. So what's the probability of no tattoo? It's the number of no tattoo divided by number of sample space, but in that case it's total, right? So total. Frequencies of same thing. Total of frequencies. So frequency. Okay, so there will be 112 total of frequencies, and number of node tattoo is 59. Can you please calculate? 0.5268. All right, very good. Okay, now let's talk about law of large numbers. So let me read this one. When we compute empirical probability, we are using data to make an estimate. So we want to make sure the data was collected without bias. And the data must be accurate and reliable. So what this means? This means if you want to ask 3 friends if they have a tattoo, only 3 friends is all too small to be sample, right? And then there is bias because convenience sampling, right? Okay. So small samples may not be diverse enough to reflect the population. We've been talking about this, right? Okay. Then if you collected data from 2,500 people, you can be more confident in the probability you calculate, right? So they say that this is known as law of large numbers. So what this means? Law of large numbers say that as the amount of data increases, the empirical probability will move close to the theoretical probability. Yeah, means that we have a experiment, then become theoretical. Like a flip the coin, we have a experiment like a 80%, 70%, 70%, 60%. But eventually, if we have a large enough the experiment and increases, that means then we get 0.5, which is 50% getting ahead. Make sense? Okay, let me explain to with this graph, and then I'm gonna show you StatCrunch simulation. Okay, so the first flip the coin, getting head is 0. After 2, flip the coin, getting luckily 0.5, yeah. But flip the coin, getting head, theoretically we know that 50%, which is 0.5, right? Okay. This graph mentioned that after 57 Phillips coin, right? Estimate getting head is 0.6316 and getting increasing the experiment. And this is a 300 Phillips coin. Then they got 0.5167. So mention that as a coin is flipped more and more times, the empirical probability, this experiment, right? Getting head gets closer to the theoretical probability. Theoretically, we know that getting head is 50%, which is 0.5. Is it clear to you? Okay, let me show you second. Okay, so let's do these questions. Empirical probability. Pew Research Center conducted race in America survey in 2019. One question in the survey asked if subjects had been unfairly stopped by police. The responses include 668 Black individuals who responded, yes, it has happened to me, and 802 Black individuals who responded, no, it has not happened to me. What is the estimate? Probability that Black American has been unfairly stopped by police, right? Okay, so let's find the probability. So probability unfairly stopped by police. Okay, so number of unfairly stopped by police. Okay, divided by total, right? Okay, so what is the total in the case? The total will be 668 plus 802. Say yes, say no, right? Okay, then number of unfairly stopped by police, say yes. Okay, now can you please calculate? 0.4544. Good job. Thank you. Okay, so let's take a look. Subjective probability. So we talk about the rain, right? So there is a subjective rain. If event E represent the event that it will rain in Dublin, Ireland on Saturday, estimate probability of event E. Okay, so let's take a look the solution. The solution is according to the weather app on my phone. There is a 70% chance. We read, right? If there is rain tomorrow, we read how many chance because next to each other, they gives us a percentage, right? So 70%. Yeah, in the case, a 70% chance that will rain on Saturday. It's a subjective. It's not based on data collected. Yeah. Okay. All right. Okay, so let's take a look this one. We have terminology here, definition. So probability distribution or probability model is a list of each possible outcome of an experiment or category of data along with its probability. Probability models are constructed the same way we created relative frequency table. Yeah. Okay, so we're gonna do that soon. All right, important point. The sum of all probability, which is relative frequency, right? We had that earlier, must be equal to 1. We had experience, right? 1 means 100%. Okay. Now, we have a rare or unusual event. We talked about the unusual before, right? When we talk about the z-score is below -2 or above +2, right? It's unusual, right? We have unusual event. They say that it's less than 5% chance of occurring or 0.05, right? Yeah. So let me write down. So unusual. When we talk about the z-score, is below -2 and above +2, right? And also here 0.05 less than 0.05, which is the same as 5%, just highlight, same as 5% chance of occurring. Yeah, hold on 1 second. 5%, yeah, chance of occurring, same, yeah. Okay, let's do this question. GPA, right? Make a probability distribution. So, or probability model. Okay, let us do that. I need this data set, so let me copy. Oh no, hold on 1 second. Okay, let me do that. Sorry about that. Okay, so there will be, I copy and paste here. So there is relative frequency. Yeah. So 3 out of 228 and 20 out of 228, 58 out of 228 and 82, 228, 55, 228, 10 out of 228, right? Okay, let me write down everything. Okay, so I got all the numbers. Can you check that whether this sum is 1 or not? Is it? It's 1? Okay. Total is 1. Okay. No, sorry. This is over. It should be like that, right? So total is 1. Which is 100%, right? Okay. Let me make another page. Okay, so let us answer this one. That was the probability distribution, the first one, right? So probability distribution. So then we can say that this is the probability, right? So there's a relative frequency probability here. Yeah. All right. Second one, what is the probability that randomly selected colleges graduate had GPA below 2.0, right? So below 2.0 here, right? So we already have that. So we're using this number, 0.0131, 32? Okay, 32. Okay, sorry about that, 32. All right, so change that, 32. Okay, second one, 0.0132. If we make a percentage, 100%, so 1, 2, so that will be 1.32% below. Yeah. Okay. C. Oh, this cum laude. I don't know how to spell. Means that student graduate with, so basically good student, right? GPA of at least 3.5. What is the probability that randomly selected college students graduated with this honor? At least 3.5. So at least means at least 3.5 or more. In that case, ooh, until 4.49, right? So we have a lot of at least means 3.5 or more. How much more? Until 4.49, right? Okay, so there will be last two lines, so we can add that. I just want to make a little bit organized. Yeah? So second part, probability of below 2.0. So C, probability of at least 3.5, right? So that will be 0.2412 plus 0.0439. Can you add that? So we have 0.2851. Good. Okay, so the last one, which of the preceding probability reflect unusual event? Oh, we had unusual event. What was it? The probability less than 0.05, right? So which one is that? 0.05. Oh. 0.05. Less than 0.05? Less than 0.05? This is unusual. This is unusual, right? Okay. So GPA, let me write down. GPA 1.5 to 1.99 and 4.0 to 4.49 are unusual. Since the probability is less than 0.05. Yeah. Okay. All right, so let us do this one. This will be the last one. We have summary of important probability properties. Okay. Let me just read this one. The probability must be between 0 and 1, including 0 and 1. We did earlier, right? And probability impossible event, which is 0, right? And certainty is 1. The sum of all probability must be equal to 1. Yeah? Like a relative frequency, right? Okay. Now, which of the following numbers could represent probability? So probability must be between 0 and 1, right? So that will be first one, not second one because over 1, not C because negative. Oh, 12 over 55. What do you get? It's less than 1, right? So D. So how much you have? 0.2812. How about 35 over 27? Bigger than 27, it's more than 1, right? So no. What about the 7.23? times 10 to the third power. Okay, so this one, let us do that. F 7.23 times 10 to the negative 3. So 10 to the negative 3 means we move to that decimal point to the left 3 times. So there will be 1, 2, 3. Yeah, if we have a positive to the right, right? Okay, so there will be 0.0, and then we insert to 0, right? So 0.00723. Yeah, is it true? Is it probability? Yes, because between 0 and 1, it is, right? So F as 1. So we have ADF. Since they are between 0 and 1. Yeah. Okay. Thank you for watching. Bye.